So let us begin with the next session. We are studying the subject Introduction to Programming in C for first semester. So today we are here to teach or to learn matrix multiplication. Previous class, we learned matrix addition. So write a program in C to perform matrix multiplication. So first we have to note down what are the inputs we are supposed to take and what will be the output. The input is first the order of the matrix A, that is M cross N, the order of the matrix B, P and Q, then the matrix C. But while doing matrix multiplication, we are supposed to follow certain rules. What are the rules for matrix multiplication? The number of columns, say n, of the matrix A, that is matrix A, should be equal to the number of rows, say P, of the second matrix B. That is, n should be equal to P. Otherwise, multiplication is not possible. So whatever the matrix, the answer you get for matrix, after you do the multiplication of, that is matrix A and B, that will be stored in matrix C. That will be called as a resultant matrix. But you have to remember only if n is equal to P. So first we should start with the library, that is to include the library that using this syntax stdio.h should be enclosed within angle back bracket. This .h indicates header file. IO, that is stdio means input output files. First, we have to define using preprocessor directives. We have to define the row and columns. Max row is a preprocessor text. Wherever this text is present, that replaces the value 6 in that place. So max row is a text and max call is also a text. The text followed by some number. That number will be written, will be copied to the text, wherever this text is present. So it's very, very easy to use always preprocessor directives. Instead of writing the value 6 and 6 like this or 7, 7. So if you are supposed to change row and columns however you want, you need not to keep changing in the program. That's why always go for this preprocessor directives to mention the number of rows and number of columns. You have to start with the main function. The int indicates the return value of this main function. So now we are declaring three matrices: matrix A, matrix B, matrix C. So in matrix A you have row as well as column. In matrix B, max row, max call. See, this is case sensitive. This text is case sensitive. How you define that only you have to write here where you need to use this. So similarly, max B, I've used a text, and max C, matrix C, row and column, I've used it. So the resultant matrix will be stored in matrix C. Now, rows and columns, two variables have declared of type integer. Then matrix B dimension, again, rows and column. This of two variables of type integer I have declared. These are the loop variables I, j, k. Have declared three variables. Now prompt and read the dimension of the matrix A. So now the user supposed to enter the dimension for the matrix A. That will be read through scanf function. So you are using that whatever the value the user will enter will store in the variable m rows and n columns. Now prompt and read the elements to the above matrix. So the total number of elements in the matrix is m cross n. So now we have to prompt the user. You have to tell the user that to enter the element for the matrix A. That is m rows and m rows bar n columns. Now using two for loops, we have to enter. One is meant for rows, other one is meant for column. So for I is equal to 0, I value is initialized to 0 first. And it will check the condition. If it is less than m rows, it will get inside the for loop. Now j is again initialized to 0. It will again check the condition whether the value entered is less than n columns or not. If the conditions are satisfied, then it will execute the scanf statement. The scanf statement, function, is reading the values, whatever the user entered, to the matrix A. So first the value of I is 0, j is 0, so 0, 0. The first value, whatever the user will enter, it will go and set in matrix A of 0, 0. Again, j is incremented. It will check the condition. The next matrix 0, 1. Again, j is incremented. Check the condition. Read the value into matrix A 0, 3. So till the condition, this condition is satisfied, it will execute this. Once it breaks, the outer for loop will be executed. That time I is incremented to 1. Now again j is initialized to 0. Less than n columns it will check. Then matrix A 1, 0. The what user enters will go and set in 0, 1. Similarly, the inside for loop will execute as long as the condition is, this n columns condition is satisfied. So this is how you are reading the values for matrix A. Now prompt and read the dimension of the matrix B. That is the order of P, Q. Now enter the dimension of the matrix B. So you read the value for scanf, that is through scanf function you read the value of matrix B. It will store in P rows and Q columns. Prompt and read the elements to the above matrix. So total number of elements in the matrix P, P cross Q. So you enter the elements to the matrix B, that is P rows by Q columns. So for I is equal to 0, I less than P rows, check the condition. Get inside, j is initialized to 0. J will check the condition. If it is less than Q calls, less than this variable value, then scanf is executed. So scanf contains, now it will read the value through scanf function. You are putting the value to the matrix B, which value it will store in 0, 0 first. Again, j is incremented. The value will be stored in 0, 1, 0, 2. So as long as this condition is satisfied. Once this condition is failed, outer for loop will be executed, I is incremented, and the value will be continued like this. So I now 1, 0, 1, 1, like that. It goes on. Again, next matrix multiplication logic. How to apply the validation as per the matrices multiplication rules. So matrix A into matrix B is equal to matrix C. The value, the answer will be stored in the matrix C. So performing the matrix addition, how do you do this? So for I is equal to 0, I less than m rows. Check the condition, it will get inside the for loop. It will get inside the for loop. J is initialized to 0. J, again, the value of condition will be checked. J less than Q calls. Then matrix C of I comma j is in a partial sum. So it is initialized to 0. Next, since we are doing the multiplication, you should be very, very careful. So K loop, where one more loop, nested for loop is important here to learn. That is, inside for loop, we are doing the addition, multiplication. So for K is equal to 0, if K is less than this value P rows, only then the matrix C of I comma j plus you're doing here matrix A of I comma K is multiplied with matrix B of K comma J. The value will be stored in corresponding matrix C I comma J. Now K is incremented. Again it will be continued till it becomes less than P rows. Once it is done, this will be J is incremented. When J is incremented, again, the matrix C of I comma j is equal to 0. So this complete loop will be executed till j less than q calls. This condition is satisfied. After that, once this condition is failed, outer for loop will be executed. I is incremented. Again, the condition it continues. So outer loop is meant for rows. Inner loop is meant for columns. This is how the matrix multiplication is done. So we understood how to do the multiplication. After knowing addition, multiplication is understood. So you should know the logic here. Very, very important is how exactly the nested for loop is framed to perform the multiplication.